Here we go. All right, so don't worry so much if you didn't get to these. These are going to be quick to write down when you get down to it. Okay, so we're talking about 263. This is the last section in this lesson. So we have a little bit of workbook work to do. We also have our chalk activity outside to do. We're just comparing functions. Same thing as yesterday, but we want to write a few things. Let me add one thing over here. This is going to be your asymptote. We're going to compare two different functions, and essentially what we're talking about is a few different elements. We're talking about, the slope, which this is increasing. What is this increasing faster or slower than, say, this part of the function down here? Which one is increasing faster, this or that? This one or that one? Which is a steeper incline if you had to walk up it? This one or that one? Right? So g of x, as far as in this portion of the graph over here, g of x is increasing faster than f of x. But look what happens. F of x isn't staying the same. Like g of x is going to stay the same. That line's going to go way up here. Not on the roof, but it's going to keep going up into forever. Okay, towards infinity. Now here, f of x starts really low. In fact, it starts at the asymptote here of 0. And it starts to get what? Steeper? Steeper. The average rate of change, or the slope, keeps getting steeper until right here at this point, it exceeds it. It exceeds it. So the f of x is going to exceed it. And you can see this right here, this steepness is what? Way steeper than what? Than that. Way steeper. But it grew to that steepness. So the point where it exceeds the other function is right here at, what's this point? 2, 2. So that is the point where it exceeds the other function. Okay. So really all we're doing, the difference is we're talking about the point at which it exceeds the other function. We're looking at the slope to compare them. And when I'm rotating it like this, it's essentially as I move up, right? And I follow the tangent, or the line here, called the tangent line. It is going to end up having a steeper slope once we get to these points, okay? So if you're like, well, I forgot how to graph any function really, you get onto the SAT, PSAT, you forgot how to graph a certain kind of function, use a table. You can always use a table. So we're going to use a table to graph the function. There we're going to compare it, increases faster or decreases faster, average rate of change, the slope, you could bring up an element of that. Point where the function exceeds the other, we know that's at 2, 2 for this one. So maybe even put a dash line here so that you can remember, okay, this is at 2, 2. At the point 2, 2, f of x exceeds g of x. So you think of it this way, right now. If these were cars that were washing, right? You were washing cars, car wash, and this was the number of hours, you're not doing too well. Because after 2 hours, how many cars have you washed?
Only 2.
Only 2 cars. It doesn't matter if your function for f of x or g of x, across streets from each other, one team of car washers has a different method, so I could denote the method of it. But I know that right here, at 2 hours, both of them have had 2 cars washed. There's not one that's greater than the other. It looks like this one had the cars coming in consistently. This one had nobody, no cars coming in, and then one car came in a little later, then they're getting more cars coming in. So I want you to start to look at graphs. For these problems, this is going to be our time, and this is going to be our amount. Okay. So write those in there actually. This is the amount. This is the time. Okay. So let's go ahead and see if we can actually do this. Because it's something we've done before, I'll take a moment. Can anybody give me a candy crux for that? What's candy crux? What's the hardest part of that? Anybody? This part is pretty conceptual with the laser. Is that a little tricky? There is total silence. Wait, I need my other sound effects. Does anybody have an idea what the Candy Crux is? That brought a hand up. Caden.
Well, kind of like wrapping my head around the time and then
Yes.
the amount.
The time and the amount.
Because
Good.
when I was thinking about it before you wrote it up there, I was thinking the time on the other side and then the amount on that side.
I see.
So it was kind of really confusing.
Okay. So if you have time as one of the quantities, it's always the x-axis. When you get to physics, it's the x-axis. In chemistry, it's the x-axis. Time is always going to be the x-axis. So I think that's great. That lets me kind of write that down or elaborate that so you can write it down. So just circle time, and let's just put time. This is always the x-axis. I can't even think of a scenario where they would make it different. Good. Okay. The other bit about it is to figure out the slope, but we're going to do that with this problem, so we'll hit it again. All right. That was all the Candy Cruxes. Huh? Okay. Here we go. Here's a function. This is 2x minus 2. We know how to graph this, but let's go ahead and pretend we don't know how to graph it. What value should I plug in for x? 0. What else? 0, 1, 2. Let's just see what's happening at the first two amounts of time. Okay. So let's see. We plug in 0 right here. F of 0. 2 times 0 minus 2. What's 2 times 0? Well, 2 to the 0 power is 1. I like that. But 2 times 0. 0 minus 2 is negative 2. So when we plug in 0 for x, we get negative 2 for y. Right? Let's do f of 1. 2 times 1 minus 2. What's 2 times 1? 2 minus 2? 0. F of 1 equals 0. You see, these are pretty quick to plug in. These functions aren't going to be crazy complicated because that's not the process we're trying to get to right now. We're just getting the content. 2 times 2 minus 2.
2.
F of 2 is equal to 2 times 2 minus 2. F of 2 is equal to 2. There's a lot of 2's in there. All right. What should we plug in for these?
Same thing.
You know what? It's good to plug in the same thing because then you see how they're relating at those exact points. If I picked 0, 3, 4, then I wouldn't quite know what's happening, at 1 and 2. We set it up here with 0, 1, 2, then we're actually saying what's happening at the same amounts of time. All right. Plug in 0 right here, g of 0. 2 to the 0 is 1 plus 3.
4.
G of 1, 2 to the first. 2 plus 3, 5. All right. G of 2, 2 to the second plus 3. Good. 4 plus 3, 7. Does everyone feel okay with doing the tables? You guys okay with tables? Okay. All right. On the quiz, I will expect you to have this work done because how long did that really take? It didn't take too long where you're going to lose points for it, right? So just you gotta whenever you're asking, do I have to write it down? Just write it down. Waiting to ask the question takes longer than writing it. All right, we got our points. We got 7 here. Let's see what's happening. Let's bring this one over. These are the elements, the components for full credit for the next part of this. But let's go ahead and graph this right here. Right? 0, negative 2. 0, negative 2. I'm graphing my f of x first. 1, 0. 1, 0. 2, 2. All right, and that looks like a line because it should be a line. That's pretty. With chalk, you're not going to have perfectly straight lines. That's okay. Or try to make that okay. I know for a lot of folks that will be hard to do. Ignore it. All right, how about g of x? I'm just graphing these points. If you're wondering how I'm graphing, I use these points. 0 for x, 4 for y. 1 for x, 5 for y. 0 and 4 is going to be 1, 2, 3, 4. All right, 1, 5, 2, 7. So we can see that it's going up. Now, this isn't the full picture of this. I kind of want to see what's happening over to the left. Like, what is my asymptote going to be? You got to have your asymptote in there. Okay, asymptote. So what's a number we can figure out? Let's plug in an x value way over here so we can figure this out. Jackie, what should we plug in? -5. I say let's go just a little further. -10. I like this. Because then you know what's happening way over there. I'd hate to do -5. You're like, I'm not sure what number it's going to. We got to figure out what it's going to as far as the asymptote goes. So -10. Let's see. 2 to the -10 plus 3. This is 1 over 2 to the 10th. When you have a negative exponent, put it on the other side fraction, it becomes positive. Now, I did this first period, so I know that this is 1,024. 215, 212, 1,024. Plus 3. How big is this number? If you have 1 out of 1,024 cookies, do you have a lot? No, it's very small. This is a very small number. 1 out of 1,024. That's really horrible chances. It's a small chance. It's a small possibility. If you did this on a calculator, it'd be like 0.0001 or something like this. So, really small number plus 3 is just, about 3. Or at least this tells me that what's happening. What's happening? It's going down towards what? 3. You going to be able to graph that asymptote? How do we find it again? We plugged in a value way over here at -10 to see what's happening. Is this function, does it keep going down or does it level off somewhere? You can pick any number to plug in. You can pick any number to plug in. So -10 was a good one because it's pretty far over there. I could have plugged in -100, -1,000, anything I wanted. All right. Thumbs up, somebody's done. Shaking. It's like a shaker. All right. So the rest of this, get open your workbook, page 175. Number 1 is the problem you're going to do with a partner. So I want you to team up with a partner. And for those at home, this is in your workbook, page 175, number 1. If you're at home and you missed it, I need you to go to that problem and go ahead and do that on a graph paper. Components for full credit. You got to have a graph. You got to write the equations. Compare 3 things. Put your names on it. Label important points and asymptotes. So before you go outside, you're going to take a picture of this. When you're done with your graph, come back in with a picture of your graph, and I'll give you the credit right now. Okay, so you have till the end of the period, and that is in. You got like 30 minutes. Jude.